Here is proof number 1 of the Pythagorean theorem. We start with our pieces being set up like this, our right triangle here, the big square C here, the big square for B there, the medium square for B, and the small square for A here. And what we want to prove is that the area of these two squares is equal to the area of this big square. We're allowed to add things, take things away, move things around in a geometric visual proof. And so what we want to do here is let's add some triangles to this. If I add that triangle there so that I have A here and B there, and then this triangle here, so I have A here and B there, and I put this triangle here, so I have A here and B there, and then I want to put in these two triangles. This one matching up A and B, and this one matching up with C. The interesting thing about this is that I can take these triangles and that square, and if I pulled them away from the triangle where we started, then what I have here are two congruent figures. Now, one is a mirror image of the other. How do we know they're congruent? Let's follow the edges. This length is B, and this length is B. This length, so we turn a right angle, This length is A plus B, and this length is A plus B. We turn a right corner, and and this length is A plus B, and this length is A plus B. And we turn a right corner, This length is A, and this length is A. And then we turn not a right angle, but we turn this corner, and we follow along C, and we're back to where we started. So we turn this corner, and we follow along C, and we're back where we started. So even though it's not quite a mirror image, you would have to pick this one up and flip it over to make it match, but you can see that they are two congruent figures. If they're congruent figures, then their areas are identical. And so what we see is, if we pull away these three triangles, we can pull away the area of those three triangles, and that just leaves the area of the big square. And I can pull away 1, 2, and this one, that third triangle, and that leaves the area of these two squares. What we see algebraically is that for this piece down there, we had A squared, the area of that square, plus B squared, the area of this square, plus 3 times the area of the triangles. So we'll say 3 times the triangles. And when we had this all together, we said its area was equal to C squared, the area of this square, plus the area of the 3 triangles. And when we pull the triangles away, we're subtracting off the areas of those triangles. So we subtract those off, and what we're left is A squared plus B squared is equal to C squared, and thus we have proved what we have set out to prove. What we want to do, if you choose this proof as the one that you memorize, then what you're going to do is you're going to have your pieces with you on the test, and you're going to set them up like this with the triangles. So you'll set them up like this, and you'll write two congruent figures. You'll label this side as A plus B. This is A, this is C, this is B, this is A plus B. You'll label this side as B. This is A plus B, this is A plus B, this is A, this is C. So you'll have this drawn, and you can use your pieces, your cutout pieces, to trace around if that's what you'd like to do. Label the sides, and then you would write this over here. The a squared plus b squared plus 3 triangles is equal to c squared plus 3 triangles. You'd cross those out, and your conclusion is a squared plus b squared equals c squared. You would draw it, you would label the sides, you would write this, and we're all good.